Welcome to today's lesson, which is 2.5 on atomic Lewis structures. Your learning target is I can draw a Lewis structure for any atom, and you certainly will be able to. Okay, so first off, what is a Lewis structure? A Lewis structure is going to oh, this is already wrong because I am doing this a second time because I didn't like the way it came out the first time. So, I'm sorry, I apologize. A Lewis structure shows the valence electrons only for any atom, shows them as dots around the atomic symbol. Okay. There's a scientist, I don't remember his first name. His last name is Lewis. He says, if valence electrons are the most important part of an atom, why are we even spending time drawing the nucleus, drawing all the protons, the neutrons, all of the electrons on the inside that don't participate in bonding? If chemistry is all about bonds, why are we even worried about that stuff? He's a genius. He came up with a super fast way to draw molecules. If I were going to draw carbon dioxide the old way, I would need 8 protons, 8 neutrons, 2 rings, and my electrons split into 2 and 6. And then I would have to arrange them to get these bonds. You get the picture. This would be a giant mess, and we can keep it super simple using these Lewis structures. We are not focused on these today. This is a molecule of carbon dioxide. This is getting very complex. We're not ready for this yet. We're starting here with just individual atoms. Okay, so this element is called magnesium. It's number 12 on the periodic table. Magnesium has 3 rings of electrons. Those electrons are split 2, 8, 2. So my first layer, the one right outside of the nucleus, if I were looking at this picture, I'm talking about this. Where's my pointer? Oh, I'm not in. Oh, stinky. Okay. I would be looking at this inner shell right here, if you're following the red circle. That would have 2 electrons, then we have 8, and then we have 2. That's what magnesium would look like. This dude Lewis says that's too complex. Just keep it simple. We're going to take the magnesium symbol, because you could look it up on the periodic table and know how many protons magnesium has. You could also figure out how many neutrons it has quite easily, how many electrons it has. We only care about those 2 on the outside. Remember those valence electrons. So we can draw them super simply. The first step is to find the atomic symbol on the periodic table. So for this example, I am going to show you how to do bromine, because bromine is one of my fave elements. It is all the way on the, not all the way, but very, very close to the right side of the periodic table. It's number 35. It's atomic number 35, meaning in its nucleus it has 35 protons. Imagine drawing 35 protons plus 35 plus neutrons. It's not actually 35. It's like 38, I think. I don't remember exactly. But there's more neutrons in this than there are protons. So you're drawing 70 something circles in the nucleus plus 4 rings of electrons plus all of the electrons. Scratch that. We're keeping it simple, okay? We are taking bromine's symbol off the periodic table. If you didn't know bromine symbol, which I don't expect you to just yet, you could look that up on table S. You look up bromine by name, and then you can find on table S its symbol is Br. Then we're going to look up the electron configuration, which is in our periodic table at the bottom of the box. That's the string of numbers right here. It's not 2 minus 8, it's 2-8. This shows us how many shells of electrons there are and how many electrons are in each of those shells. So here, this is telling me, because I have 4 numbers, that bromine has 4 rings of electrons. It has 4 orbitals, okay? My first orbital is on the left. It has 2 electrons. My second has 8 electrons. My third has 18 electrons. And my valence shell is going to be the one all the way on the right, showing me that I have 7 valence electrons. Okay. Then what we're going to do Now that we know the number of valence electrons, we're going to draw my valence electrons as dots. If bromine has 7 valence electrons, it needs 7 dots. I'm going to put an imaginary box around the symbol. I'm going to start drawing my dots, my electrons, at the top. I'm going to put 1 electron at the top, and then I'm going to move to the side and give my next electron. And I'm going to continue around the sides of the box until I've drawn all 7 of my valence electrons. All right, so I have 1, 2, 3, 4, 5, 6, 7. And then I can remove the imaginary box. Now, if you draw the box, you are using your chemistry training wheels. Our goal is to be riding 2-wheeler. Okay, we don't want training wheels forever. If you need to start with the box until you get the hang of it, that's cool. That's fine. I'm not going to judge you, but you got to learn how to do it the way a chemist would. So if you draw the box, do it in pencil and then erase it. Okay, if you can just imagine the box being there, good for you. That's already 2 steps ahead. All right. So that is how you would do the Lewis structure for bromine. I'm going to rearrange this so you can see a bad structure for bromine. Okay. If I just put my electrons wherever the heck I wanted them, like this, that would be a bad version of the Lewis structure, because they're just kind of like thrown all over the place. And if you remember that the electrons are negative, these guys are not going to want to hang out near each other. They're going to want to be far away from each other. So this whole bottom area is completely empty. Lewis, the scientist, said, you know what? We have to have a protocol so that everybody's Lewis structures kind of just look the same, right? We don't want Joe's Lewis structures looking different from Bob's Lewis structures. We want all scientists to know what we're talking about at all times. So he kind of has this nice wrap it around the box. So let's say I had 5 electrons. That's what it will. Let me take out the symbol. Let me just put in, can I change the text here? There we go. Let's change. Oh, no, I'm not changing the text because that is not the right thing. Let's just make this element J. There is no J on the periodic table. Did you know that? So we're going to put an imaginary box around J. If J had 1 electron, it would look like this. If J had 2 electrons, it should look like that. If it had 3, aluminum, for instance, aluminum has 3 valence electrons. Its Lewis structure should look like this. Carbon with 4 valence electrons would look like that. Nitrogen would look like this. Oxygen has 6 valence electrons. So does sulfur. This is embarrassing. How do I not know this off the top of my head? Yes, it's sulfur. Woo. Sulfur also has 6 valence electrons. So does selenium, Se. So does tellurium, Te. All those babies have 5 valence electrons, so their Lewis structures would look like this. 7 valence electrons. This would be fluorine, chlorine, bromine, iodine. They all have 7 valence electrons, so their Lewis structures would all kind of look the same. Again, we care about the valence electrons, not the protons. That's why we're drawing them like this. The box is so that everybody's Lewis structures across the whole world kind of have some uniformity to them so that we can look at it and everybody understands what it means. Okay? Welcome to the club. You now know what a Lewis structure is, what it stands for, what it means. You just became a bigger, brighter chemist